Well, welcome back to Yates American B244. My machine is missing the motor tag, which is normally on this cooling shroud here. But based on the dimensions of my motor and based on the dimensions of other B244 motors that do have the motor tag, I think mine is a 10 horsepower motor. In this segment, I'm going to disassemble the stator from the machine and assess whether the windings are salvageable or not. Assessing the windings and making sure they're okay is kind of a big factor in deciding whether I want to continue restoring the machine or not. So let's get started. Because all these leads are bare, all of them are bare. The fabric insulation and rubber insulation on these are just disintegrating. So I'm going to loosen these bolts, but I'm going to leave them in place so I can knock off this bell. I don't want it to pop loose and then fall and break. Okay, so the bell is completely clear of the stator. It's held on by these two here. So let's see what we got. There's the inside of the bell. The usual mud dauber nest. Oh, that's interesting. So there's an outboard bearing here to support this end of the motor. Well, let's take a little tour. So this outboard fan, which I presume that's what this is, has had a brazing repair on it. So I wonder what happened that broke. So it looks like there's sawdust packed all around the stator winding. And there's exposed windings right here. I wonder why those are exposed. Maybe they may be exposed as a result of whatever broke this fan. Well, I'm definitely not the first to get into this thing. This is probably broken from someone trying to pull that off in the past. The end of the shaft is all scarred up, and a couple of these tabs on that spider washer are broken off. Oh, there's one tab broken right there. I don't really know what I'm getting into here. I'm confused by this cone nut and the spider washer. I mean, that combination of items is usually associated with tapered roller bearings, and this is a cartridge bearing. So I don't know what I'm really getting into here, what's going to be underneath all this, or even if I'll be able to get underneath it. It's pretty tight. So I've been contemplating how to try to remove this fan and the bearing and everything. I've been trying to figure out if there's a way to make a tool that would fit around this little ledge right here and pull it off that way. So I started on something that I might be able to use as a puller. So I'm kind of guessing at this profile here, but I'm hoping that it will fit around that. So I'm going to fasten these together and then split them apart so they can be clamped around that ledge and see if we can pull the bearing off that way. Here it is initially welded up. There it is cut in half, one half of it anyway. So I'm hoping that'll be enough grip to pull things off. This is just mild steel, so we'll see. Okay, I think I have my special puller finished. However, I couldn't get one side to fit because this brazing is sitting too proud. It wouldn't sit flat. I tried using a sander to work on it, but that didn't work. I also tried using just a file, and that was like really slow. What I ended up doing is just using a wood turning scraper. Anyway, let's see if this thing fits on. There goes nothing. Well, now that we've got this pulled out a ways, I'm going to take this special puller off and just use the gear puller like it normally would. Now that the bearing and spacer are knocked off, I'm hoping that that fan will be able to come off without much trouble. It looks like there's just a keyway, maybe it's a slip fit. So I thought I'd go ahead and put this big gear puller on here, and I've been able just with hand pressure, I'm getting this fan off. Okay, with the outer bearing and that spacer and the fan removed, the next task is to get this stator off so that I can assess the condition of the motor leads. There's no way to get the rotor off with the stator in place. However, I'm still convinced that when the machine was built, the stator, the field windings, were probably placed on before the rotor, because that would afford a whole lot more room to navigate the stator and get these wires fished down through here. So getting them out, I'm going to just do the best I can. The insulation on these leads is damaged all the way up to the windings. And I probably did some of this damage just now, but the wires are bare all the way up to the windings there. Okay, I pulled the stator off. I pulled the field winding off. Let's take a quick look at this rotor. So there's the inner fan. It looks like it is undamaged and unrepaired. And what I find interesting is in some other articles about the B244, there's a fan here, and then there's another fan on the inboard side, but there is no fan attached to the rotor. Interesting little difference. Before working on the stator, I thought I'd go ahead and clean it up a little bit. Now that we have it out on the machine, let's take a closer look at this stator. In addition to these areas where it looked like it took a hit, or maybe someone was using the windings as a fulcrum, there's this scar. Can't really see it well here, but there's a spot here that looks like it took a hit. And we know about the leads all being bare. I hope this is in focus, but what I haven't noticed before is there's a spot here that looks like it's shorted out. And there's a little area here that I can't quite tell what's going on. This looks like one of the leads coming up here. Okay, well, let's start opening this up and see if it can be repaired. Try as I might, the insulation on the leads is just shattering. Just brittle. And there's some windings back behind there. just to give you an idea of how brittle this insulation is. I want to temporarily put some shrink tubing on these leads to re-insulate them, but I first want to tin the ends of them so they don't come undone. You have to really make sure you keep the wires marked. I got all the leads temporarily isolated with some shrink tubing, and I took some measurements. So all the Y circuit is all 0.6 ohms, and then all the other circuits, all the other leads are 0.3 to 0.4 ohms. So they're consistent. I think the stator is good, except that the some of the leads need to be repaired. So I sent a bunch of photos of the stator to Caldwell Electric in Waco, Texas, to see if they would be able to replace the leads. They replied saying that they wouldn't be able to. They'd have to rewire the whole motor for $1,000. I'm going to set this aside and evaluate the rest of the machine, and I may come back and see if I can replace one or two of the leads that are in bad shape.